All right, so what we're going to be talking about today is calculating the heat of a reaction using a slightly different method. So I know yesterday or Monday we talked about calculating the heat using stoichiometry. So that was the first page. Now we're going to go to the back side of this note sheet and we're going to talk about another way to calculate the heat of a reaction, and that's using something called Hess's law. So let me just show you using these two reactions up here. This isn't necessarily how we solve a problem, but what I'm going to show you is things you're allowed to do to the equation. So this is perfectly legal. We can do this, and the reason why you want to do this is you want to manipulate the equations to get whatever equation you want. So that's going to make more sense in a minute. But I'm just going to show you what you're allowed to do. So the first equation I want to show you what you're allowed to do is you're allowed to just multiply by some sort of number here. So it's almost like taking a recipe and like doubling it. If I double the ingredients, I'm going to double the product. So I'm going to do the same thing, only I'm going to multiply by 3. So you're allowed to multiply or divide any reaction you want by any number you want. So I just arbitrarily chose 3. I'm going to multiply by 3. So that means all the coefficients, 3 times 2. So now that's going to turn into 6. This is going to be 3 here. And this is going to be a 6. So I'm allowed to multiply by any number I want. Now what you have to remember is if I multiply the reaction by 3, I also need to multiply this delta H, or the amount of heat, by 3. Because if you think about it, if I triple my ingredients, I'm going to triple the amount of heat that's being produced. So this comes out to be, when I multiply by 3, this comes out to be 1450.8 kilojoules. Okay? So that's just one thing you're allowed to do. You're allowed to multiply or divide by any number you want. You just have to remember that if you do that, you also have to multiply the delta H by the same number. Okay? The other thing you're allowed to do is you're allowed to reverse these reactions. So let's look at this second reaction and let's see what that actually means. So I want to reverse this second reaction, meaning this N2O, this is a reactant, and this N2 and this O2 are products. So what I'm allowed to do is I'm allowed to actually just take this arrow and flip it and turn it around the other way. So now N2 and O2, these have now become the reactants, and the N2O is now the product. So all I did was I flipped the reaction and I basically turned it, around. So now instead of releasing a certain amount of heat, now the reaction is going to absorb that same amount. So what you do in that case, if you flip the arrow, if you flip the direction of the reaction, you want to flip the sign here. So instead of negative, it becomes positive. Okay? So those are the two things you're allowed to do to all reactions. You're allowed to multiply by some sort of number or divide by some sort of number. And if you do that, you have to multiply the delta H by that same number. Or you're allowed to flip the sign. And you can do both. Like I could flip the sign with this previous one here if I wanted to, and I just have to flip the actual negative to positive, or vice versa. Okay, so those are the only two things you're allowed to do. Multiply or divide by a number, flip the arrow. If I flip the arrow, I got to flip the sign. Now, when you do this, what we can do at this point is we're allowed to, and this is where Hess's law comes in. Hess's law says you're allowed to actually add these two reactions together to make one big reaction. Okay, so how I'm going to do that is I'm just going to recopy this. So I'm going to take the reactants first. So these are the reactants of the first reaction. And I'm going to take these and I'm going to rewrite it into, I'm going to make one big equation out of these two. So I'm basically going to combine these two equations together. So that means I'm going to start with 6 H2s, because I multiplied by 3, plus 3 O2s. So there's my reactants from the first equation. Now, remember we flipped the arrow of the second equation, so these guys are now the reactants of the second equation. So now what I'm going to do is I'm going to add those to this super equation here. I'm going to add these two together. So that means that's 2N2 plus O2. So I've combined both of the reactants together into one equation. Now what I'm going to do is I'm going to do the same thing, only I'm going to do it with the products now. Let's just change the color. Just so it looks a little bit easier to see. So now these are the products of the first reaction. This is the product of the second reaction. So I'm going to add those two together now in the product side of the equation. So 6H2O plus 2N2O, N2O, and that's it. So those are my two products. So I have now combined these two equations together into one equation. Now Hess's law says if you do that, you are also allowed to add the two delta H's together to get the delta H of this reaction that you added together. So if I add negative 1450.8 and I add that to positive 163.2, I'm going to get negative 1287.6 kilojoules. Okay, I just added the two delta H's together. Hess's law says if you add the reactions together, you are also allowed to add the delta H's together. And that's really it. Those are the things you're allowed to do. Okay? Now that you sort of have an idea, okay, that's what I'm allowed to do. Now let's see if we can figure out how to like manipulate these. What number do I put in front and when do I flip the arrow? Okay, hopefully those are some questions that you guys are asking. So here's how we do this. The problem looks like this. It says here's a bunch of different reactions. It could be 2, could be 3, could be 4, could be as many as they want to put in here. In this case, they're going to give you 3 different chemical equations here with their different delta H's. Now, here's what the problem is saying. Use these 3 equations, manipulate them, add them together so your final equation will look like this. Okay, so that's the goal. The goal is to take these 3 equations, manipulate them, and so when I add them together, it equals this equation down here. Okay, so the way that personally that I think works best is I'm just gonna use this as my template. Like this is what I want, so I'm gonna work off of this. So the first thing I'm gonna do is I'm gonna look for, all right, I need an N2O. I need that, and I need it to be in the reactant side of the equation. So I look back at my 3 equations here and I find N2O. And it turns out that the only place where I'm going to see N2O is right here. Okay, so I've sort of isolated where that's at. So now if I go back to what I want to find, I want an N2O in the reactants. Well, this N2O is already in the reactants, so I know I don't want to flip the arrow. I want to keep it going that same direction because I want this in the reactants. All right, now the other part is I only want one N2O in my final product here, but there's 2 in this equation. So what that means is I'm going to have to divide everything by 2 because I want to get rid of that 2. I just want one of them. So if that's the case, I'm going to go through, I'm going to divide this by 2, I'm going to divide this by 2, and I'm going to divide this by 2. So that just becomes 1/2. So I'm allowed to multiply or divide any of these numbers by whatever I want. Okay, now remember, if I divide all of these coefficients by 2, then I also have to divide the delta H by 2. So I'm going to do that, and when I do that, I get negative 81.6 when I just divide by 2. Okay, so that's the first thing. All right, now next, so I've sort of isolated the first thing in the equation. Now I want NO2, I want that to be in the reactants, and I want one of them in the reactants, NO2. So I come over here and I look for NO2, and NO2 I see is right here. So I'm going to go back to my pen here. So I need NO2 to be in the reactant side of the equation. Well, it's in the product side of the equation right now. So that tells me that the first thing I'm going to have to do is I'm going to have to flip the arrow. I'm going to turn this the other way. So this NO2 is now in the reactants. And when I do that, don't forget, I got to flip the sign. So the negative becomes a positive anytime I flip that arrow. So the NO2 is now a reactant because I flipped the arrow, which is what I want. I only want one NO2, but there's two in the equation. So once again, I'm going to have to divide everything by 2. So that becomes 1/2. This is 2 over 2. So I'm going to cross these out because this basically just becomes 1. So 2 over 2 is 1, 2 over 2 is 1. This 2 over 2 is 1, and that 2 over 2 is just 1. Okay, so I flipped the arrow, and I divided by 2, which means I'm also going to have to divide this number by 2 as well. And when I do that, I get positive 56 point, I believe this is 6, if you round this to 1 decimal place. Okay, so I took care of the N2O. Now I took care of the NO2. So now the last thing that I need in my equation, let's use orange, is I need 3 NOs in the product side of the equation. So now I'm going to go back up to my 3 equations. I'm going to find where do I see NO in these equations? Well, I see one of them here, or I actually see 2 of them right here, and they're in the products. So that's good. And then I see another NO right here that's actually in the product because I flipped the arrow. So when I add these together, I'm actually going to get 3 NOs in the product, which is what I want. So I'm not going to do anything to this equation. I'm not going to do anything to that one. I'm going to leave it just the way it is. Okay, and then I'm just going to add all these together and make sure that it equals this last equation here. All right, so now this is where it gets a little bit tricky here, but I'm going to start with this equation number 1. And I'm just going to I'm going to add all 3 of these together. So I'm going to add the reactants. So the reactants are NO2 for this first equation. Now I'm going to add the reactants to the second equation. So the second equation, the reactants are N2 plus O2. Okay, so then I'm going to add the third equation. I'm going to add the reactants together, which is N2O. So I've taken all 3 equations and I've added all the reactants together. Now I'm going to do the same thing with the products. I'm going to go back to reaction number 1, and it looks like the products here are 1/2 O2 plus NO. So that's equation number 1. Equation number 2, the product is 2 NO. Okay, and then I'm going to add the third equation. I'm going to add the products together, which is N2 plus 1/2 O2. So I've just taken all 3 of these equations and I've added them all together into one equation. Right, now what I can do is I can just combine stuff together. So it says NO2 plus N2 plus O2 plus N2O. So there's nothing really I can add on this side. However, on this side, I can take this 1/2 O2 and that 1/2 O2, and I can add those together. So that makes 1 O2. And now I can also add these 2 guys together because this is an NO. There's 2 of them and there's 1 here. So I'm going to end up with 3 NOs. And then I have my N2. Okay, so I'm just combining things together. Now, the last thing I can do is if there's anything on either side of the equation that's the same, I can cancel those out. So there's an O2 on this side and there's an O2 on that side. So those actually cancel out. There's an N2 on this side and there's an N2 on that side. So those actually cancel out. And then if I sort of rewrite this, and I'm going to just flip these around just because I want it to look like the first equation. So it doesn't matter what order you put these in, but I'm going to put N2O and NO2 on the left side. And then I'm going to put 3 NOs on the right side. And I'm going to go back and check to make sure that this actually equals what I wanted it to add up to, which is N2O plus NO2 yields 3NO. So I was able to add these equations together to get to this final equation, which is what they wanted. Now, they want to know, what is the delta H for this equation? So remember, if I add these three equations together, Hess's law says I'm also allowed to add the delta H's together. So I'm going to add 56.6 and positive 182.6 and negative 81.6. I'm going to add all those together. And when I do that, I end up with 157.6 kilojoules, which is my answer. And I just need to put it down here at the bottom where I got 157.6 kilojoules. And that is positive. Okay, so that is my answer to this question. So again, just to sort of reiterate, any of these type of problems, I want to figure out, how do I manipulate these equations so when I add them together, I get this final equation that they want me to get. Okay, so the practice problem is the same thing. You have three equations here, and then you have this equation that they want you to find. So what the question is asking is, how can I manipulate these three equations so when I add them together, I get this final equation here? And when you do that, you add up the delta H's, and that's going to give you your answer.